And I'm live on 8:30 Prep. It's Phil McCaffrey. How are you on May the 4th, 2020? We are now into our third calendar month of quarantine. And I've been doing 8:30 Prep as a way to have some fun, write some material for books and students of mine, as well as have something to do that doesn't drive me out of my mind while we're all sitting around waiting for the world to come back. So we're back to normal. We're back to math. And today we're going to be talking about functions. So 8:30 Prep is going to be about the function of x. What's your function? And so when I said, what's your function, what came up to my mind was conjunction, junction, what's your function from the great Schoolhouse Rock when I was a child. And Damien, say hello to Damien.
What's up?
Damien used his Apple software. What was this software?
Pixelmator.
Pixelmator. He pixelmated me onto, I'm sure this is copyrighted by Schoolhouse Rock. So for all the viewers that are watching out there, please do not tell Schoolhouse Rock that I'm stealing their iconic conductor of conjunction junction from them. All right, where did this f of x come from? You can all blame this on Leonard Euler, and that's how you say this. He was Swiss, born in Switzerland. Those countries all moved around a bit. Lived in Berlin and died in St. Petersburg. He was a mathematician that was about 100 years or so after Newton, so he was in the mid-1700s. I guess I could have read his Wikipedia page a little bit better than just stealing his picture. But this is Euler, and he made the famous function of x. The primary reason we use this symbol was that in Euler's day, they were still using like Harry Potter parchment quills and pens to do math. And he was working on some extremely large polynomials and figuring out calculus. And they came up with a function instead of rewriting the polynomial over and over again. They came up with the function of x and the function of g, literally to save ink. So you can blame him for all of this mathematician stuff we have. So what is a function? A function is a relationship involving one or more variables. It's a relationship between variables. Like what? Well, here's a classic function. And there's two variables here. This is your age, and this is your height. It is the stature of boys from age 2 to 20. This is the famous height-weight chart that when you go into a pediatrician, the first thing they do is weigh you, put you on a scale, and measure your height because you follow this function. That is, your height is a function of your age. And if you grow along normally, if you are a normal person and you progress along normally, then all of a sudden you start getting taller and taller. You move off the function line and there's something medically wrong with you. Just like as if you stopped gaining height or weight and you leveled off, they would look to see if there's something wrong with you. Maybe you had a growth hormone problem in your thyroids, or you had a deadly illness. So this is the function chart that everybody is used to at the pediatrician. The function that everybody knows and that you should know, particularly if you're a student of mine and you're watching, is that y equals mx plus b. Now this is 4 letters, but there's only 2 variables. There is x, the input variable, and y, the output variable. M and b are represented here by letters, but they're constants. So the function depends upon the input x, the output y. And so y equals mx plus b can be written as a function of x. So the function of x is equal to its output. The x variable is not equal to the output unless it is the variable, the equation where y is equal to x, and that's the very rare one. It is something that the function is dependent upon the variable. So we're going to look at a classic and talk about the vocabularies, and we'll look at some functions and do some problems, and then we'll go through what standardized testing does with functions. So right now, function vocabulary, what you do need to know is the input variable. And the associated number of input variables is the domain. The output variable is associated with the range. We could also call the input variable the independent, and y, the output variable, the dependent. Y depends on x, what you're putting in. So your height depends on your age. Your age doesn't depend on your height. It's the other way around. That's a good way of putting it. Actually, I like that one. So y depends on x. The function of x depends on what we're putting in to this linear function. And here it is in graphed form, where x is the horizontal, is always the independent, it's always the input. Y is our vertical function, it is always the dependent, and it is always the output. And math teachers love to use the same equations over and over again. Call this the equation. Let me rewrite that equation. Y equals 2x plus 5. We could also write this as the function of x is 2x plus 5. Notice m and b here. B being the y-intercept would be the value of 5. M being the rise over the run. So for every 1x I go, I rise up 2 y's. All right, mapping. This is something that you're taught in algebra. It's not really important for standardized testing, but it does kind of sort of come up every once in a while, and that is each input variable has only one matching output variable, but not the other way around. In order to be a function, each x has to have one y that matches it. It only has one value. So, and this is where we'll get with the vertical line text. So if we use 2x plus 5, if we use here is x and the function of x equals 2x plus 5, and we put in 0, we would get 2 times 0 plus 5 is equal to 5. So the function of x here, this ordered pair would be 0, 5. If we put in 1, we would get 2 times 1 plus 5, or 7. 2 would give us 4 plus 5, which is 9, and so on and so forth. These ordered pairs, there is only one value. And you might have seen something like this, or here's a parabola, excuse me. We'll do the mapping circles next. In a parabola, if we have 1 and 2, and -1 and -2, and let's say this is just the simple one where y equals x squared. If I put in 1, 1 squared is 1. If I put in -1, -1 squared is also equal to 1. So 1 maps to 1 and -1 maps to 1. There is only one value for 1. There is only one value for 2, but there are 2 y's. So both 1 and 4 and 1 and 4, the y's can have, the outputs can have multiple inputs that map to it. And that's where this part is. When you saw 1, 2, and 3, they can map to the same y value, call this y1 and y2. But what can't happen for it to be a function is x1, x2, and x3. You cannot have x1 mapping to y1, but also to y2. This is not a function. It's still an equation, it's still useful. There's a ton of things we do with it, and I'll show you that. Okay? For example, on the ACT and currently on the SAT, they love the equation of a circle, x squared plus y squared equals the radius squared. This is an equation, and it does function well. As a matter of fact, it's the basis of trigonometry. Sine squared plus cosine squared equals 1. But if I have a singular cosine or a singular x, it maps to two different y's. So I can have x1 here, but it's going to go to y1. It's also going to go to y2. That is not a function. And we say the vertical line test, if I draw a line through the function that's vertical, if it hits two values of y, it is not a function. That has been tested. Which of the following is a function?
Peyton says, are you tired today?
Am I tired today? Do I look tired today? I actually feel kind of tired today all of a sudden. No, I've had a great day. I got up really early and I worked on this, and I've been working on ACT all day long. But I guess I don't have that same power and vigor in my voice. I even took a little nap today. I came over to the office and did some tutoring, and after I was done tutoring, before I finished this, I slept in my chair.
I think it's me. I think I bring your energy down.
You're bringing my energy down. You're bringing my vibe down. Okay. This is a parabola on the side. This is x equals y squared, and it fails the vertical line test. It is not a function at all and in any way. All right. So let's do a couple of simple function problems that are on the standardized test, and then I'll make some worksheets. Tomorrow we've got 4 days of function. Tomorrow I'm going to do function translations and do the parabola dance and try to make a TikTok. Yes, I'm actually going to try to make a TikTok. It's going to be Damien's going to help me, so we're gonna do this. And then Wednesday and Thursday I've broken it into problems from the ACT on functions and problems from the SAT on functions. And the SAT definitely loves functions and loves it in more ways than the ACT. So Thursday is going to be big on that one. All right, so here's a standard ACT style question. If the function of x is equal to 3x squared plus 7x minus 8, what is the function of negative 3? I just read about 10 ACTs. And the function of negative 3 was on 4 out of the 10 of them. This is pretty amazing to me. I'm like, wait a second. They always use negative 3. So now I'm interested. I have to go back and read my 70-plus ACT test to see how often they use negative 3 as the input. So this is my value of my input. What is the output? What is the function? What do I do with the negative 3? I look sleepy. I do feel sleepy. I'm going to get a good night's sleep tonight, that's for sure. You take the negative 3 and you put it wherever there's an x. Now, the one thing I will say is when they use negatives, please use your parentheses on your calculator. I brought my calculator down. So the parentheses right here on the TI-84, definitely use it, because if you put in negative 3 squared, that'll be negative 9. Negative 3 squared is not the same as the negative 3 quantity squared. So let's put in 3 times the quantity, negative 3 squared, plus 7 times negative 3 minus 8. And we're going to get 9 times 3, which is 27, plus 7 times negative 3, which is negative 21. I put a positive sign there. And negative 8. So 27 plus negative 29 gives me a negative 2. The answer for this is the function of negative 3 is equal to negative 2. And I'm just realizing I didn't do any of these problems beforehand. So we're live. This is definitely 8:30 Prep Live. And then here's a separate test. These are literally questions I copied off an ACT. And there again we see the function of negative 3. If the function of x is defined as negative 6x squared, what is the value of negative 3? The one thing I didn't put on here, which I will on Wednesday when I go over the ACT, is they have every mistake you can possibly make. And you literally just put in 6 negative 3 squared. Negative 3 squared is 9 times negative 6 is negative 54. And you can bet your sweet patootie that 54 positive is one of the answer choices And it is wrong. All right, one more. And that is the function of the g is defined of g of x of y of z. You can put in more than one variable. And, of course, on Wednesday, we'll do the classic function of g of x, where we put g inside of x. And so this function is defined as 4xy minus 3xz squared. What is the function of 2, 4, negative 3? So what do we do with these? The 2 goes in for the x. Ooh. The 4 goes in for the y. And the 3 goes in for the z. It's a negative 3. So let's be very careful here. We're going to go with 4 times 2 times 4 minus 3 times 2 times negative 3 squared. Notice how many times they have negative 3 squared. That's 3 in a row. I didn't do this on purpose. This is just what the ACT does. 4 times 4 is 16 times 2 is 32 minus 3 times 2, which is 6 times 9, which is 54, which we have on here, and the difference being 28. Jeez, Phil. The difference between, let's use our calculator. I am tired, Peyton. Minus 54. I better check 22. Boy, I blew that one. I was, wow, out of my mind. This equals negative 22. That's the answer. Okay, so what is a function? A function is a relationship between two variables, often plotted in the xy plane. It can have 3 variables like it's shown here. Tomorrow we're going to do translations of a function, and that is how a function moves around the xy plane. It's going to be a really short night tomorrow night. Wednesday and Thursday, I'll have some worksheets. I'll post them up online. If you'd like to get the worksheets from me beforehand, I will be working on them tomorrow. Drop me a line at phil@3R Prep, and I'll send them off to you. If you'd like to do worksheets, I'll probably start doing worksheets in advance. I'm going to start making a lot of worksheets. I was working on about 5 or 6 today. Anything else on that one? Oh, there is one more. Okay, here's a backwards one. The function of x is 2x plus 3. If the function of a is equal to 11, what's the value of a? This one screws up a lot of students. It's an old SAT problem. I've seen a similar one to it on the ACT, which I'll show next because I do have one more problem. And that is a is the input and 11 is the output. So we're going to write 11 is equal to 2 times a plus 3. And solve for a. 11 minus 3 is 8. 8 equals 2a. A is there, equal to 4. So the function of 4 is equal to 11. And then here's the very last one. I really like this one. It's a really old ACT problem out of my archives, but I thought it was pretty cool because it showed the function of 5 is equal to 12. Which of the following functions satisfies the function of 5 is equal to 12? And if I put in 5 for each one of these, like this, what do I get? 5 squared minus 13 is equal to 12. That's my answer. 5 squared plus 13, more than 12. That's going to be 38, but I'm doing really well here. This is going to be negative 2. It's wrong. This is going to be 37, and this one's going to be 65. I didn't do so bad on that one. So B, C, and D. B, C, D, and E are all wrong. A is the correct answer. The function of 5 equals 12. I kind of like this problem. I'm going to keep this one, and we'll be using it on worksheets. So that's it. I'm Phil McCaffrey. It's 8:30 prep. I'm sorry I look sleepy, Peyton. I'll try to wake up for tomorrow and drink more coffee. I'll try not to get up at 7:30 in the morning. That was the big problem. And now I'll be tired and go to bed and wake up at 7:30 again. I usually try not to wake up that early, so I'm wide awake at 9 o'clock at night. I'm Phil McCaffrey. Thanks for watching 8:30 Prep. I'll see you tomorrow when we do conjunction, junction, what's your function, the translations of functions, and the parabola dance.